Hey guys, this is Anshul, and I will be demonstrating the decorator pattern in this video. Uh, Now, the decorator pattern is essentially used for in cases where you want to add functionality to your class, to an existing class or your existing objects. So essentially, it should be following the principles, which is the single responsibility principle and the open closed principle, which means in case of open closed, the class has to be open for extension but closed for modification. And single responsibility means it will have a single functionality associated with it. So we'll see that in this example of how the decorator pattern works. So let's define our includes. The first one is IOStream, and then we will have string, and let's have functional. So I'll start with this simpler case, and we'll build on it. Now, in this first case, we will be creating a logger, and we'll build the logger to another level. So let's take a simple logger at this point, which is, uh, let's call it logger, and we'll add an std function to it. So this is going to be our wrapper function, which gets invoked. And let's say uh, in this example, we will have a void function. So this function takes a, a, a function. So our function is essentially initialized by void function, which returns a void and it doesn't take any arguments. And let's call it func. And we will give this a name, and the name will be an AME. And let's have its constructor, which will take the arguments const std function void as a reference. Okay, and the second argument is going to be the name, and we will initialize our variables here. So func is initialized and name is initialized. Okay, and for the logger, we will have an operator, a function operator, and this is how we will invoke it. So, and it doesn't take any arguments in this case, and we will simply uh, output entering the, and this will be the name of our logger, right? And we invoke our function over here, and then we exiting, and then name of our function. Okay, so this is our simple logger structure, and we are going to invoke this. So let's define our main. And here we will create our object, which will be logger, and let's call it logger1, or I'll just call it as logger, and initialize it with a lambda function in this case. So our lambda doesn't take any arguments, and we pass it in to the logger structure. So this is going to be our function essentially that is going to be invoked over here in the function. And we will say hello. And let's give this a name, which will be logger1. Okay, so this is how we will define our object, and in order to invoke the functionality, we call logger like this, and return 0. Okay, so this is the basic logger. Let's invoke this. Okay, so we have our statements entering logger1, hello, and exiting logger1. So this is the most simplest implementation at this point. But here you see that we are just passing this function which doesn't return anything, and it doesn't take any arguments. So let's build another logger which will be a little bit more sophisticated as compared to this one. Um, and this one is going to be based on template. So let's call template type name, and we will call it as func. Okay, and the structure is going to be logger2. Okay, and instead of having a std function, we will create the template func. So this is our template type parameter, and then the name is name. Okay, and this logger2 is going to have the first argument as the template argument. Second one is again going to be the name of it. So let's call it reference name. And we will initialize the arguments. And I think here I missed to put the name. That's why we were not able to see the name earlier. Okay, and there you go. So this is the constructor, and now we will define the operator, the functional operator again for this. And it will have a very similar structure, so I'm simply going to use the same structure over here. Okay. And now let's modify this one to be logger2. So instead of logger1, we will have logger2. And now you see there is a problem over here at this point. And it essentially does not understand this lambda function. So uh, the templates, the logger2, where we are using the template type name, it cannot derive the type of this lambda function in this current CPP version. So in order to overcome this problem, we are going to make another function which will instantiate our logger2. Okay, so let's call this as make logger2. Okay, and to this we are going to pass the function and the name of this logger. So we will call this std string reference name, and this will also be taking a template type parameter. So we'll call this func, and this will return the logger2 object, and we will pass in the function as a part of it. So we have func and name. Okay, and okay, so this should be giving us the logger2. So now we are going to put an auto over here and call this as logger2, and we will invoke make logger2 and pass in the lambda function that we have, and the rest of the structure remains the same. So you see now we are able to achieve the same outcome, but our function can be different. It doesn't have to be limited by a void return and no arguments. So we can pass a different type of function over here and get a different output. So this makes it more extensible. Um, so let's execute this. And also I need to change the function call operator for logger2. So let's invoke this. All right, so we have entering logger2, hello, and exiting logger2. Okay, so again, the same output, but this is a different way of implementing the same thing, and it gives us a bit more extended functionality. Now, at this point, we still can improve upon this, and the third logger is going to be a much more sophisticated version of the existing logger. So in this case, we just use func, but what in cases where you have to pass variadic arguments, it can be a little bit more challenging because this logger2 does not accept any of the variadic template arguments at this point. So we need to have another implementation which will give us the functionality such that we can pass it variable arguments and get the outcome. So to exactly show you what I'm trying to make over here is something like this. So I have logger3, and let's say we'll call it as make underscore logger3. And to this, I can pass in a function, okay? And we'll give it the name as add in this case. So essentially, we have this function add, and which takes argument A, argument B, and let's say we output the value of these, the sum of the parameters over here. So we will have A plus B, and we will get A plus B, right? And this, and we'll return A plus B. Again, this statement is redundant over here, but anyways, this is just for the purpose of demonstration. So this is what I want to achieve. Have another logger3. So instead of invoking add directly to add those two integers, I want a wrapper function which will not only add but also do the logging. So I can pass in the add function to my logger, and it will do the necessary invocation and do the logging as well. So that's the idea. And that's why make logger3 is going to be our wrapper function. So the logger3 is our wrapper object which will perform the addition, as well as it will uh, log log these values as well. So let's build this. Now this is struct logger3. Okay, and this is also going to be a template type parameter. It's so the first argument that we will define is going to be the return type. So let's call it type name R. And the second argument is going to be the Variadic list. So this is a list of arguments that we pass to it. Okay, and here we will define a function again, which will be uh, the return type is R, which is the result, and it will take variable arguments like this, and we'll call this as UNC. Okay, and we will have a name for it. Let's call this NAMB, and we will create the constructor for this one, which will take a function. So this will be a const std function, and the return type is R, and then it has variable arguments like this, and we call this as func. Okay, and the second argument is going to be the name of this function, of this logger. So let's call it name, and we will initialize our func and the name. Okay, so this is our constructor, which will take in the std function and initialize the function over here. And we are going to take this again by reference, both of these, and initialize our variables in here. And now our operator is going to look a little bit different. So in this case, I want to be able to return the sum of the two values, or the result essentially. So our argument can be anything, but I want to return the result based on those arguments. And this will take in, let's say, args, the variable args, and here we are going to invoke our function. So we'll say entering name and and here we invoke our function with the variable arguments like so, and we exit out of it. Name cd and okay, so this is going to be our logger3 structure. Now, in order to invoke this by using make logger3, and we have to pass in the add function pointer to it. So let's build our make logger3 at this point, and this is also going to be a template function, and we'll take in R as the input and type name args like so, and we will call this as auto make logger3. So this will return a logger3 object, and the arguments are going to be, let's say, a function pointer in this case, and which will take the arguments, the variable list of arguments like this, and the second parameter is the name. So we have const std string and call this as the name, like so. And now we will return a logger3. Now, there's one more change that we need to do for our logger3 to work correctly. And before I go ahead with building the logger, we will need to do a partial specialization of our logger3, which means we need to have something like this, template, like name, struct logger3, okay? And over here, we will specialize it. So this is our partial specialization right here. Okay, so now we will be able to invoke logger3 with these arguments. And let's build the final logger3, which will look like this. So we will have logger3, pass in the template arguments, which will, so this is our specialization, the partial specialization, so it will look like this. Okay, and to this, we will pass in the arguments, and those will be our function. Now, in this case, we are passing a function pointer while our constructor accepts a SVD function. So we will create an SVD function object by using our function pointer. Okay, and this is how we will do that. And we'll invoke the constructor of our SVD function, and we'll pass the function to it. And then we'll have the name of this function, and let's call this as logger3. Okay, and this is it. Okay, and in order to invoke our operator, so it is going to take variable arguments. So the way we are going to invoke this operator is we will call auto result, and we don't need this anymore, so I'm going to take this off. And auto result is going to be equal to the logger3. So here we build our logger, and then to logger3 we are going to invoke the operator, which will take in, let's say, 1 and 3. Okay, so we invoke it like this. A lot of things which we're missing. So one is the operator. I missed to add the brackets over here, which is why it was not able to detect it. And let's add the result here. So the result of our function call will be stored in result, and we will return result from here. Okay, so that's the whole invocation, and now our logger3 looks fine. And I think once we invoke this, hopefully we should get the right output. Alright, so we are entering logger3, 1 plus 3, and I think I should put another equal to because it's confusing. So I will go back to the add function over here and put an equal to sign here. and then run this again. Okay, so we have entering logger 3 and then it uh, adds 1 and 3 and gives us the result and exits. Okay, so what we have accomplished in this case is that we have a logger tree is uh, which is a wrapper on top of our add function that we defined over here, and it creates a wrapper on top of the add function. So it not only does the addition, but it also logs it in the logger. So we are able to achieve the wrapper functionality by using this form of logging. So I hope this was helpful. And this is an example of the decorator pattern. And I'll be creating other videos for different types of patterns as well. So thank you, and you have an amazing day. Bye bye.